Hello students, coming to Java programming course, Unit 2, and we know that Unit 2 consists of two chapters. Chapter 1 classes and objects, Chapter 2 methods in Java. And Chapter 1 classes and objects we covered in Unit 2 videos, and these methods Chapter 2 covered in 3 videos, video 3, video 4 and video 5. This is video 5 now. And these are the topics we are going to discuss in this video now. Recursive methods, nesting methods, overriding methods, attributes like final and static. And we know that recursive nature for methods generally reflect in calling methods. The method calling itself is called the process of recursive and recursion. And second topic, nesting of methods. Nesting means one method consisting of another method. So this is possible. Sometimes we may call one method call into another method call. Third one, overriding methods. Overriding means it is similar to like overloading, but not but it's different. Comes mostly in inheritance property of an object-oriented programming, and we will discuss there this topic clearly. And in this video, just we will see the brief introduction of this overriding methods and the two keywords final and static. Coming to the topic 1, recursive methods. Here, Java supports recursion as usual. That recursion is the process of defining something in terms of itself. That it means that a recursion process consists of calling method to itself. And as it related to Java programming, this recursion is attribute that allows a method to call itself. A method to call itself is the process of recursion. And we know that a method that calls itself is said to be recursive in nature. Here this method, we call that as method a recursive method. An example of this recursion, and we know there are many problems related to this recursive approach, and we design methods based on this recursion process for solving in real time to make the process of doing of those problems or giving solutions to those problems, and it is coming to an efficient approach. And here the example of this recursion is computation of factorial of a number, factorial of a given number, and it is the process of finding factorial of a given number, and we can design a program for solving this problem, finding factorial of a given number. And this approach, and we can solve this problem by two approaches, recursive approach, non-recursive approach. Whereas in non-recursive approach of this problem, and we create or we define one method that finds factorial without calling itself. And whereas coming to the recursive approach, we design one method of fact, and every time during the process of finding this factorial, it calls the method itself. Then we call that a classic example for recursion, factorial of a given number. So for your better understanding, the factorial of a number, capital N, is the product of all the whole numbers between 1 and n. Between 1 and n. So we know that, for example, factorial of 3 or 3 factorial is, and we will written in a symbolic representation 3 factorial like this. So the factorial of 3 is what we said, that product of all whole numbers between 1 and n. Now n is 3. So we are taking the values 1 to 3. 1, 2 and 3. 1, 2 and 3. And we will take this product 1 into 2 into 3. Now its the value is 6. So factorial, 3 factorial is nothing but 6 factorial. 3 factorial is equal, what is the value? 6. The product of all whole numbers between 1 and 3 is 1 into 2, 2, 2 to 3 is 6. So this is the way we find factorial of a given number. Now coming to here, how these recursive methods can be called, and what is the difference between this normal method call, recursive method call. So for better understanding, so here in our Java programs, in main class we have a main method, and in this main method usually we call many functions to call for the execution, right? And whereas coming to here, I have a recursive method of type return and a static method. And static method can call without creating any object. So we can happily call by the name of this recursive method, and whenever we call in main method of Java for call to this method, so when we call this method, that it is nothing but a normal method call. Normal method calling. When we call by name, the function will execute at this moment of position of this main function, the control flow, and shift to this recursive method and for this execution. And what is the recursive method call? So recursive method call nothing but the body or scope of this recursive method. Inside this body, we make a call to this method itself. Here this method, recursive method calling itself inside, and not only one time or two times, it is calling itself for execution. So this is the way we represent a recursive method call, and the difference between this normal method call and recursive method call. The function calling itself, here it is clearly indicating that inside of this function call, this method calling itself, so that's why we consider this process is called recursion. Next one, example to consider what the sequence of recursive calls made to find the example factorial of a given number. And see here, generally we know that the product of all whole numbers between that number 1 to n. So here if you observe this one, sequence of recursive calls. For example, I want to find a factorial of 5. So 5 factorial. So what it mean of 5 factorial here? And you all know about this one. It is a product of the whole numbers from 1 to 5. 1 into 2 into 3, 3 into 4 into 5. So what is the product? So is product is equal to 120, and it is very clear. So but what actually, how to design this process into a program, right? See, the logic of solution to this problem is this 5 factorial is nothing but, and we are going this way, 5 into 4 factorial. 5 into 4 factorial. What this 4 factorial means? This 4 into 3 factorial. 3 factorial means 3 into 2 factorial. 2 factorial means 2 into 1 factorial. What this 1 factorial indicates? 1 factorial is 1 into 1. 1 to 1. So this, the value it returns is 1. So when it returns 1 here, so the product of this 1 factorial with 2. So this the sequence, the value written from each recursive call. So thus we design a recursive method for finding factorial of a given number. So every time we consider this is recursive 1, iteration 1, this is the first call to recursive call to find 4 factorial or 5 first 5 factorial, then 4 factorial, then 3, like that. Now coming to here, the values returned from each recursive call. So here 1 factorial returns 1. This 1 is copied here, and it 2 into 1, it becomes 2 factorial. So this value is returned to this position. 2 factorial is nothing but 2. So then 2 factorial, nothing but 3 into 2 factorial. So 3 into factorial of 2 is nothing but 2. So what is the value it gives? 6. So 6 is written to here. 4 into 3 factorial, 4 factorial means nothing but 4 into 3 factorial. 3 factorial is nothing but 6. So 4 into 6, 24. So 5 into 24, 120. So 120 is the final one returned for this method called recursive method for finding factorial of given number. Understood? And go to the example of program logic design. We come to here. This is finding factorial by the use of recursive method. I have a class called Factorial. Inside this Factorial, I have designed one method called fact, and the return type of this fact is int. The return type of this method is fact method is int. That it means at finally in the end of this body function, it returns one integer value. It returns one integer value. So this return type of methods should return and should contain a return statement in the body of the function or a body of the method at the end. And in between, you can design your logic for finding factorial. And I have designed one result value for finding facts. Every time fact value returning a value, as we seen in the last example of previous slide, and here taking this result value to return. And when if n equal to 1, but we are passing a value to finding this fact of int n, that it means when we call this factorial method and we pass one integer value to find the factorial. So that the way this method is designed. So when this n value is equal to 1, then simply it returns 1. Otherwise, it executes this statement. This is called recursive step here. So here, this statement takes that what is n is not equal to n, not equal to 1, then it simply calls the function itself by doing like this, n into fact of n minus 1, n into fact of n minus 1. Like this until it becomes n, this function calls itself in a recursive approach. And coming to the main class recursion, inside main function, I have defined one object of this factorial class, and here this statement prints first thing f dot fact of 3. So an object is class f is an object of factorial class, here factorial class, and this object is allowed to call this fact method, and here f dot fact of 3. So we passed one integer value here as this function expects. So fact of 3, and we know that process fact of 3 how it finds. We see an example clearly, and I will show you the tracing process also. A fact of 3, like fact of 4, fact of 5, you can find many numbers. Fact of 3 is 6, factorial of 4 is 24, factorial of 25 is 120. Got it? Coming to the example tracing program, and we have given this fact of 4 like this example, and we designed the example. This is another type of factorial logic, and not equal to, and it simply makes this one, otherwise this. This is another type of logic for finding the same factorial of a given number. And when we pass given value 4, that 4 is copied into this parameter of this fact method, and this n is taking into here n into fact of n minus 1. Now the n value is 4, n minus 1 nothing but 3. Got it? So now coming to here, and this 3 is copied here, and again it calls n minus 1, that is 2, and n minus 1, that is 1. And when it is coming to n not equal to, else its condition is failed, and it simply returns 1. This 1 is copied to here, this fact of n minus 1 is replaced with 1, and here this n minus 1 factorial replaced with 2, like that. Here it is n equal to 3, and this 3 into 2 is 6, returns 6, like that. 24 returns. So finally fact of 4 is 24. So this is the tracing and executing the process of designed program for finding factorial of a given number. Coming to next topic, nesting of methods. Nesting of methods means one method calling another method in the process of execution. Like that, a method of a class can be called by an object of that class using the dot operator. And this process we already know about this one, a method called by an object of the same class. A method of a class can be called by an object of that class using dot operator. So there is an exception to this for doing this in different way. A method can be called by using only its name by another method of the same class. This is called the process of nesting of methods. In a given class, one method inside one method, or any one method is called by its name by another method of the same class. Another method of the same class. So here we are not involving object because the both methods are the members of the class. So both methods having rights to call each other. So this process we consider a nesting of methods inside a given class. Example. So here I have a class called test. Two instance variables AB and one constructor with two parameters, and the two parameters are used to initialize these instance variables A and B, like this. This P in is initialized with A and Q value is initialized to B. And coming to here, method, a method of class test called greatest. So inside of this method, and the body of this greatest method consists a logic to find which one is the greatest value of this AB instance variables of class. So we are comparing if condition, using if condition, if A greater than or equal to B. When A greater than or equal to B, it returns A, that it means it returning the greatest value among the two values A and B. Otherwise, it simply return the value B. So this is a method defined inside of this class test and one constructor for initializing those instance variables when an object of this class is created by passing two values. Right? This is the behavior given for this test method, test class. And coming to the main class now, before going to main method or main class, so we have another method called display. So whereas this greatest method finding the only greatest value of given two instance variable A and B of class test, and this method display method also displaying the greatest value by calling this greatest method inside of this display method. And the body of this display method consists of an instruction to call the greatest call to a greatest method of the class test. And whatever the call made to this the greatest, it returns one value, and we know that it checks the two values of A greater than B of a instance variables of test class. When A greater than or equal to B, it returns A, otherwise it returns B. Something is returned when we call this greatest method. So to hold that return value, here this display method defines one variable called great or great, and it simply displays on the screen the greatest value of among AB of a test class, and we are displaying this greatest value. And coming to this class temporary class, and inside of this main method, we are trying to create an object of this test class by doing like this. Test is a class name, T1 is an object, and we are using this new operator for allocating or creating object of test class by using the constructor. And what constructor here is used is parameterized constructor, and two parameters must be passed. So here two parameters 25, 24 as passed as parameters for this constructor. Then, as I told you in the previous videos like this, some part of memory is created for this object. The reference to this memory location is T1, and here it allocates memory for two instance variables of class test, that it is A and B. And by using these two values, and these two values are passed into P and Q, and P is initialized with A, then P is nothing but here it is 25 and Q is 24. So P is loaded into initialized to A value, that it is here it is value 25, and Q is used to initialize variable B, that it is 24. So this is the memory snapshot of an object T1 when this statement executed. And we are calling through this object display function, display. So the control will shift to display, and it is going to execute these two statements. So the first statement is calling to greatest function, and greatest function simply compares these two values, and when A greater than or equal to B, if condition. Here is A value is 25 and B value is 24, and this condition is true. Then true means it simply returns A, that is the greatest value. So A is copied into this variable greatest, and what is the greatest value of that? This class is 25. It simply display on the screen like this, 25. So here the process is, inside of one method of the class, we made a call to another method of the same class. There is No object is involved in the process of nesting of methods, and we know the rest of process is same as creating object and calling methods of the class through object of the same class. Got it? Coming to method overriding. This is one of the feature added to object-oriented programming languages, and this overriding concept is specially designed for Java language, where here inheritance concepts will come into picture. In a class hierarchy, in hierarchy of classes, nothing but one class properties are extended to the another class, and in a hierarchy, that properties of upper class can be adopted or extended to lower classes. And and we know that superclass nothing but a what the properties are inherited from, and subclass is nothing but a class which inherited the properties by another class. So that is subclass. So when and we may have this superclass may have some methods, subclass also may have some methods, and this overriding is the concept of related to methods between this class hierarchy is nothing but superclass and subclass in relation. So here, when a method in a subclass has the same name and type signature as the method in its superclass, then the method in the subclass is said to be override. The method in the subclass is said to be override the method in the subclass. So this is very very important. When we have one method with name and type some type in superclass, and the properties are inherited to class subclass, and when the subclass defining a method with same name and same type signature of the superclass method. So there this process of doing this type concept is called method overriding, and we will see this one clearly in the concept called inheritance in the third unit, second chapter. And when an overridden method is called from within a subclass, it will always refers to the version of that method defined by the subclass. And inside of this subclass scope, this override method can call, and the version of this subclass method only call. That the version of method defined in the superclass is hidden, completely hidden by this subclass override method. And we'll see these process and more clearly in the inheritance concept, how this overridden method can be done in that class, and how it hidden the superclass method, and how to do this one like. And coming to this one, the rules for Java overriding. Here it is the first one. Method must have same name as in the parent class. Subclass method should have the same name as in the parent class method. Step 2. What is the step 2 here? Method must have same parameter as in the parent class. Name should be same and parameter list also be same. And the third important condition is there must be is a relationship among the classes, parent class and child class. Is a relation is nothing but an inheritance concept. Kind of relation nothing but an where it is delegation, inheritance and delegation, right? You know those concepts well. And coming to one example for this method overriding in Java, there is one class called shape class, and this shape class having one method called draw. And when this shape class properties can be extended to square class, shape class properties can be extended to square class, and inside this square class it may have a method called draw, same name with the parent class shape, and This is the process of doing method overriding. And the same way, the shape class properties can be extended to circle class, and this circle class also have the same method name called draw for drawing circle objects. And hexagon class extending the properties of shape class, and here also it organizes a method called draw to draw this hexagon object, right? So here this way we can override the method of the superclass into a subclass for doing this process of, right. Okay, coming to the topic like here, final and static keyword. Generally we know that Java consists of some access modifiers like public, private and protected and default. And sometimes access modification, generally we know that for the class members and methods and classes even we specify these access modifiers, but sometimes we have non-access policies like non-access modifiers. And these are the access modifiers: private, we know well, no access specification considers that as a default, and protected and public modifier. And we already gone through these topics well. And again, we will discuss these access modifiers in inheritance and packages concept. And coming to the next one, non-access modifiers, static, and these are the keywords that are used for non-access modifiers. When you use these keywords for defining a variable or a class or a method, then there is no particular access of those things, right? And mainly we will see in this topic static and final. We will come to this abstract and some more these keywords like this, and we will come to those later in further coming upcoming topics. Coming to the first one, final keyword. The modifier final keyword may be used with variables as well as methods and even for classes also. And we can define a final variables, or we can define final method as a final, and even we can define entire class as a final. Is it possible? If a variable is declared as final, it makes it constant. That it means the value of that variable cannot change in an entire program processing. When we define a variable as a final, the value is always constant and cannot be changed during the program execution. The value is assigned right in the beginning, that is considered as constant and final value, and that value cannot be changed. Cannot be changed means you are not allowed to modify or you are not allowed to apply any changes or processing. When you are applying processing, it is good, a good, better, and but not change the value into the memory location of that variable. Example, and we will see example for only declaring or defining a variable as a final, and we will see final method already covered in the previous ones, and the final class we will see in upcoming concepts. Set a variable to final to prevent it being overridden or modified. In a class main, I have defined one variable x of type integer and as final and initialized one value that is 10. It is fixed and x equal to 10 once it is initialized, and it is the constant and final cannot be changed or not allowed to modify. Inside of this main function, I am creating an object of this class main, my object. I am trying to access this variable x to initialize with value 25. 100% it will generate an error because it cannot assign a final variable. Final variable cannot be used to assign a new value during the program scope or criteria. So this instance variable is not modified or not allowed to change. Got it? Coming to the static keyword. Normally, a class member must be accessed only in conjunction with an object of the same class. Class member may be an instance variable or a method of a class, should be accessed, right, with through object of the same class. But however, we know that it is possible to create a member that cannot be used by itself without reference to a specific instance. That it means we can allow to create a member of a class without accessible through not only there is no condition to access that method through object. It can access without creating any specific instance of a class and without reference, and we can make a call to that method or a member of a class. To create such a member, precede its declaration with keyword static, like the previous one, final space int space x, that variable x is as a final. The same way, static space int x, that it means x is a variable of type and it declared as static. When a member is declared as static, it can be accessed before any objects of its classes are created. As it is the statement we learned, we must be aware. A static member, either it may be a variable or a method of a class, can be accessed before any object of its classes are created and without reference to any object. You can allow to access that one. And you can declare both methods and variables to be static members of the class. Coming to example to better understand this one. So I have a public class demo. I have defined one method hello as a static method, and I am displaying this method. When it is called, it displays hello khid. And I have another method called hi, and I have defined this method as a public method or nothing but a member of this class, right? So here it's when we call this hi method, it displays on the screen hi khid. And coming to inside main method, I call a call to static method, that is hello. I make a call to hello as it is valid without creating any object of demo class. We can make a call to this method, static method, without creating any object, right? But we cannot make the same with public method because it is a member of class. Even though this static method is a member of class, but we cannot make a condition that it should be accessed only through the object. It can call and access without any reference or insert any instance of that class. And before creating any objects, you can allow to call this static methods, not public methods. 100% when we make a call to public method or public member of a class like this, it creates a compile error. And to access that one, we need to create an object of this demo class like this. And happily you can call this hi method using that object of demo class. And this is the process to call to the public method of the class through object. So when we make a call to these two functions like hello and hi, it simply display on the screen hello khid, hi khid. So this is the usage of static method declaration, and we will see some more examples in the further concepts about static and static variable, static method, and like those. And coming to these are the references we collected the content of this video through different examples. Thank you.